Welcome to a demo of my top 10 shortcut tips for the Cynthesizer Workbench, one of a series of basic training videos for the Workbench. There's a separate video that is an introduction to editing features, so I don't want to simply duplicate that content. Instead, in this video, I'll predominantly concentrate on combinations of individual features to demonstrate productive workflows. Much of what I'll demonstrate will use shortcut keys, since that's one of my favorite ways to get things done very quickly, and using the shortcut keys is sometimes not obvious to all users. So here we are in the Cynthesizer Workbench. The first thing I'm going to demonstrate is a collection of features that would help during the iterative editing and simulation of your design. So let's do that in the context of a small example, and we'll open a simple P2P. And here we have the initial windows for that project. So let's take a look at a number of files. And we'll start with the file dut.cc. We simply double click on that, and here we have it in the code editor. Now, just as a quick aside, if the font in this window is a little small, you can easily modify it with a few keystrokes. If you hold down the Control key and press the plus, you will see the font get larger. If you hold down the Control key and press minus, it will get smaller. And Control 0 will set it back to its default. If you have a scroll wheel on your mouse, you can also hold down the Control key and use that scroll wheel to set the font to whatever size is convenient. And Control 0 back to its default. Another very useful shortcut key is the F4 function key, which allows us to switch between a CC file and its sibling header file. So if I press the F4 key, this will switch me directly to dut.h, and I can switch back and forth very quickly. This is a convenient way to switch between the definition of a class, usually in a header file, and the implementation of the class over in the CC file. This is something you tend to do very often. So in this case, we have a basic design. Everything is edited and ready to go. What we would usually do at this point is go and simulate the design to check its functionality. In this initial design phase, we would be most likely to focus on a simple behavioral simulation, and we've one set up here in the simulation configuration called B. Let's go down and select that. Now, there are a number of ways that you can run a simulation. You could simply right-click on the sim config and select Run from the context menu. Alternatively, you could select the sim config and press the Run button over in the Action button pane, or you could select it and press Ctrl R. These latter two actions rely on having a configuration selected in the synthesizer project tree to provide the context of what to run. So let's run this simulation. When I press Ctrl R, we see the job launches, starts to build. And when that compilation is finished, the simulation runs and we see the expected output values on the screen. This is the initial set of values that we would expect to come out of our design as it's currently implemented. So let's make a small change and see what effect that has. I'll press the Escape key to get rid of the output pane, and we'll take a look at the code. The input to this design is of type DT1, and the output is of type DT2. What we would like to explore here is what would be the impact of making the output type slightly narrower, i.e. reducing the number of bits. First, we need to see what the type DT2 is currently defined to be. Now, remember, if I hold down the Control key and hover the cursor over any symbol, that symbol becomes a hyperlink, as you can see here by the fact that they're turning blue and have a line under them. So if I go and click on the DT2 symbol, the editor will take me to the definition of that type, and I can see that it's an SCUint11, which means it's 11 bits wide. So let's modify that and set it to something relatively simple, and say make it something like 3. Now you can see here during editing that whenever we change a line, the editor will insert a change bar next to the modified line to let you know where changes have occurred. In addition, if a file has pending unsaved changes, there will be a star up here next to the name of the file. Now what we often want to do here is to look at more than one file at a time. There are a number of ways to arrange the editing panes to our taste. At the current time, we have multiple files open, as you can see here in the Open File menu selector. However, visually, the panes are all stacked on top of each other. With this visual arrangement, we can cycle through them using Control-Tab. If we want to split the pane, we could use the split buttons up in the top right corner, or we could simply use the key sequence Control E 3. This will split the pane vertically. I can now go over to this pane and pick the other file that I'd like to see. As you can see, this is getting a little cramped. We can always hide or show the sidebar by pressing Alt 0. And we just have our editing windows, which is what we are most concerned with at the current time. Now, we've made our editing change and we want to resimulate. We don't need to use the mouse and go back to the sidebar to do that. Remember, the last thing we selected in the synthesizer project tree was the B simulation configuration, so that remains the active context for any shortcuts or the Run button, even though the sidebar is not visible. So, I can make a change to the code and immediately press Ctrl R to run that simulation again. This is a convenient way of iterating through the tasks of edit, simulate, and checking results without having to go searching through panes and clicking on things with the mouse. Now, that simulation is run, and obviously the values are not even close to what we would expect. So we can again hit Escape, Escape, go back and make our width something a little more reasonable, say 10, and press Ctrl R again. You'll also note that the files are automatically saved whenever I attempt to build or run the design. The change bars turn to green and the star disappears from the file name. As you can see, we have much more reasonable results this time. Let's get rid of the output pane and let's remove the split. Again, we could use the Remove Split button in the top right hand corner, or simply type Ctrl E 0 to remove all splits and take us back to a single pane edit. Now, if we wanted to engage in some debugging activities, we could come down here and click just to the left of the line number and place a breakpoint. A red ball will appear here as a visual indicator of the breakpoint. Simply pressing F5 will start running our current selected simulation configuration in debug mode. Now remember, this is still the B sim config, as we can see over in the sidebar. With this debugger, you have all the standard debug facilities. I can hit F5 a number of times, each one of which constitutes a continue operation, and you can see the values changing in the variable trace pane. I can also do things like go down to a line of code, click in it, and press Ctrl F10, which is another very useful shortcut which says run to the current line of code. I can now look at something in that specific stack context and press F5 again to run to the next breakpoint. Shift F5 will stop debugging, and I can hit Escape Escape to get rid of all the panes and take us back to the standard edit view. I'll remove the breakpoint to clean up. One other interesting feature of the editor is the ability to refactor. Now, refactoring involves the automated changing of code and symbols under some user direction. There are a number of different kinds of refactoring, and I'll go over a couple of them in this demo. This function f has a pretty uninteresting name, so I might want to change it to something more meaningful. If I select the symbol f and press Ctrl-Shift-R for refactor, I get a pane that allows me to type in a new name for this symbol, perhaps something like myfunk. I can also go down and look at all the lines of code that will be modified should I decide to go ahead and perform the refactoring operation by simply opening these tree branches. All the symbols that would be changed are highlighted in yellow. If I go ahead and perform the refactoring operation, you can see that it changed the call to the function, the implementation of the function. If I press F4 to go over to my header file, you'll see it also changed the definition of the function. This is a very useful way of changing the names of symbols, whether it's variables or function names, throughout your design, and have it consistently update all references to the symbol. Another common and interesting action that one often takes is to add arguments to a function. Here, for example, I might decide that I want to pass in an extra Boolean argument to indicate whether clipping is to be performed. Bool do clip. And you can see a small light bulb has appeared, and this indicates that this declaration and the implementation over in the CC file are no longer consistent. So if I simply click on that light bulb it will go and automatically update the implementation to match the declaration. Now, you can change either one of those and it will automatically update its partner. There are a number of other refactoring features that I'll let you explore on your own. So let me press Alt-0 again to get my sidebar back, and we'll go look at some analysis capabilities. By simply double-clicking the synth module called DUT, we can pull up an analysis pane for that object. Here I can view a summary of multiple synthesis configurations. Here we have two, Basic and DPA. From the same source code we've generated two RTL outputs, and they actually have quite different characteristics. Here we can see that there are different sizes, and the DPA configuration is quite a bit smaller than the basic configuration. So we may want to go and understand why. Again, we would usually hide the sidebar at this point, so I'll go ahead with Alt-0, and we can guide the analysis of our synthesis configurations directly from this summary view. If I right-click on the DPA configuration and select Analyze, I can look at various things that might be of interest. Here in the parts table, I can see that I have a multiplier, and this is quite small and quite fast. I can go back to the summary view and do the same thing for the basic configuration. Now, whenever we want to compare two things, it's usually convenient to do that in a side-by-side view by simply selecting the Split button, selecting side-by-side, and choosing DPA in this side. I can now see both synth configs view side by side. Now here we can see in each that we have the multiplier part. For the basic side, the area is 109 and the timing is 0.57. For the DPA part, the area is 58 and the timing is 0.39. So let's try and understand why those two are different. The best place to start to look at that is at the actual Verilog code that was generated for each multiplier. Now, each of these synth config analysis views has many panes available, each able to display a different kind of interesting data. Since there are so many, we usually hide some of them to reduce clutter. Let's go and add the Verilog RTL pane to our list and select the Verilog file that contains our multiplier implementation. You can see here in the basic config that the multiplier is a standard 2 input, 1 output multiplier. However, over in the DPA version, Cynthesizer created a special part for this operation and recognized that this is really a multiply by 7 and thus only needs a single input. It's folded the constant into the multiplier. This custom function is much smaller and faster than its more general counterpart, hence the different design. So let me remove the split and go back to our synth module. So this summary view of the synth module is a convenient place to kick off the analysis of your various synthesis configurations without having to go back to the sidebar and search through your synthesizer project pane. Here is a summary of all the shortcuts I demonstrated for you today. We've also built a much more substantial list of shortcuts in document form. This Cynthesizer Workbench Shortcuts document is available from the Synthesizer knowledge base. Simply log in and search for Workbench Shortcuts to get your copy. That concludes the demo of my top 10 shortcut tips for Synthesizer Workbench. Please review the other videos in the series to learn all of the common tricks for getting up to speed as quickly as possible.